So today we're looking at word problems. This problem is a mixture problem where we're mixing $5 and $10 bills. Let's read it. After donations were collected, the treasurer found that they had collected $1,220. If there were twice as many $5 bills as there were $10 bills, how many of each type of bill were collected? So we need to see how many $5 and $10 bills were collected. First, let's create a chart. The first row will be the $5 row. We'll have a $10 row, and we'll have a row for the total. The first thing we want to know is the number of bills. How many $5 bills are there? How many $10 bills are there? And how many bills are there total? And the problem did not tell us that. But we do know a relationship between them. We know there are twice as many $5 bills as 10. So if we have X be the number of $10 bills, there will be twice as many $5 bills. So 2X will represent the $5 bills. If we add all the $5 bills plus all the $10 bills, we will get the total number of bills, which will be 3X. Now, with that knowledge, we move to our second column, which will be the value of a bill. The value of a $5 bill is 5. The value of a single $10 bill is 10. We don't know the value of the mix, so we'll leave the last part blank. If we multiply the number of bills times the value, we'll get the total value in dollars. So now, we know that if you multiply, say you had 6 $5 bills, you'd have $30 because 6 times 5 is 30. So if we multiply the value of a bill times the number of bills, we'll get the total value. We'll do the same thing here. The value is 10. We have X bills. That'll just become 10X. So we don't have to show those parentheses. And then if we add these together, we should get our total. But this time, we do know the total. It's 1,220. So we have 3 columns. Our first column we put in our unknowns, and it provided us with a starting point. It is unfortunately not a solvable equation, though. We'd end up getting 0 equals 0. It would be true for any value of x. The second column provided us a way to create the third column, but is itself not solvable. Finally, the third column provides us with an equation that we can solve to find x, the number of $10 bills. So we write out that equation next. With our equation now written out, we can simplify it. 5 times 2x is 10x plus 10x equals 1,220. 10x plus 10x is 20x, which is 1,220. To get x by itself, we need to divide by 20. So we'll do that to both sides of our equation. These will cancel out, and we get x is equal to 1,220 divided by 20 is 61. Now we need to do some interpretation. So if x is 61, x was our number of $10 bills. So there are 61 $10 bills. By that same logic, we can multiply 2 times our x value. So 2 times 61 is 122 $5 bills. And that will be our final answer. We can check our answer, if we so choose, by going back to this equation here. Does 61 in place of x answer this and make it truly 1,220? So we try that. 5 times 2 times 61 is 610, plus 10 times 61 is 1,220. So it does satisfy our equation.